one of the key issues around the prevalence of increased digitization is, of course, the problem of big data. We now have a situation where there are more IoT devices on the planet than there are human beings, capable of generating gigabytes of data every day. So what do you do in a situation where we're almost drowning in information? And for me, the biggest issue is, what are we doing with that information? How are we directing it most appropriately? So the key drivers that I see in helping us manage that process going forward are things like cloud computing, edge-based computing devices, as well as the prevalence and increasing importance of things like artificial intelligence and machine learning. So if I were to unpack those very simply, a cloud computing solution really refers to being able to aggregate data from a variety of sources into a single point that you don't actually own, right? So it exists in an environment that is supported by a third party. So it could be Amazon, it could be Google, it could be Microsoft. And what they're doing is they're creating an engine of processing power that allows you to port your information into that, and you can run all sorts of process analytics and investigation onto the data without needing to invest upfront capital in having those computers yourselves, or the cybersecurity of those systems, or even the maintenance of those systems. So it really unlocks a new potential for businesses and cities to be able to leverage those massive supercomputers that exist somewhere else. I mean, we can have access to them on a pay-as-you-go basis. So I only pay for the information that I'm processing when I'm processing it. So it has unlocked incredible potential. And then linked to that, the cloud computing capability, we can start to add different analytical processes, such as, for example, if I stitched in a camera feed from a city street, I could unlock facial recognition, which was otherwise not possible when it was originally installed. And what we're doing is we're just turning data into an actionable insight. And the second component is edge computing, where now consider that there's a camera that can distribute terabytes of information at any given moment in time, or over the course of 1 hour. That's a lot of information that's to travel between data centers and back to the point where we need to introduce that change or effect that insight. So we're looking at devices that are actually capable of doing a lot of the analytics at the point of source, and thereby making the amount of data that's being transferred as minimal as possible, so it reduces the operating cost. And then artificial intelligence and machine learning, what that's essentially referring to is the ability of our processes, our computing power to learn and to adjust, and really to mitigate the repetitive roles that would otherwise fall upon a human being in a control center, whereby we then unlock that human being to take more active decision-making arranged around what do we do with an insight. So artificial intelligence would be applied to, for example, CCTV camera, to be able to either do some facial recognition or some proximity sensing, so people are getting too close in a high-risk COVID environment. Then that makes it possible for the human being to then act upon that information. Otherwise, before that happened, a human being would have to watch the CCTV camera and wait for people to get too close to each other before saying something is wrong. We remove that issue out of the process, and it means that we can get more accurate and more punctual about our response as and when it occurs. We spoke about some of the major technologies that are going to be impactful. The one thing I didn't touch on, the future of the digital twin, is something that I think needs to be considered as well. It's the ability to create a virtualized digital version of reality that exists for the point of view of not just allowing someone to see what is happening and where, creating a 3D model of a city and linking it to the notification of incidents, a traffic jam or a car accident or a crime, and seeing these blips occur around the city. But really what we're talking about when we mention a digital twin is the ability to understand the downstream impacts of that. So if there is a traffic jam, does it mean there's going to be an impact on emergency services to get to certain locations within the city? Does it mean that waste collection is going to be impacted? Does it mean that bus transport routes are going to be delayed? And then to institute a situation or a framework of delivering information to all of those downstream impacted parties and stakeholders so that we can take corrective measures before they become a problem. And the other thing that I think is important to note about a digital twin, that it allows for scenario planning. So what if a skyscraper were to be built on the site? What if that residential tower were to be half occupied? Or what if there was to be a fire in this area? What if we converted all roofs of our buildings to create solar-powered energy? At the moment, it's difficult to actually hypothesize what the impact of something like that might be, but a digital twin allows for that scenario planning. Even from the point of view of when you leverage artificial intelligence, you can create the equivalent of thousands of scenarios in a single hour. And it would allow then our cities, both private and public cities and own precincts, to really get ahead of problems and to fine-tune their response well ahead of the problem. In fact, we could have used a digital twin even to understand what the impact of work from home might be on our cities with regards to traffic, with regards to CO2 emissions, with regards to the provision of services and even electrical capacity. That could have been done. So a digital twin essentially unlocks the potential for us to not just react to what we call the new normal today, but to hypothesize any number of situations so that we can prepare ourselves for the next normal.